Yeah, good. 7 coffees in, and the fact that I went to bed at 4 is not so bad. I was finishing slides, I was not perfect. Start?
Before Bryn will start, just a quick announcement or a quick message. There will be 20 minutes break after this session, and the refreshments will be in the deep building. So take a break or a quick lunch or something. And Bryn.
Thanks. So, welcome to my talk this year. My name is Bryn Reeves. I'm a software engineer. Huh? I was going to fade it out for the next slide, but I need to stand near the mic, don't I? Okay. I'm a software engineer at Red Hat. Some of you may have seen my previous talks. I worked in Red Hat's support engineering group for many years. Shifted over last year to the device mapper and LVM development team, but I still have some kind of fingers in the support pie. In particular, a package that we ship called SoS. I call it SOS and an SOS report. Other people say SoS. That's fine if you do that. I gave up on the battle of how to pronounce it years ago. SoS, SOS, whatever works for you. So I'd just like to relate some tales from the trenches here. Some of the adventures that we've had with the package. It's around 10 years old now as an upstream project, and it's been shipped in Red Hat's enterprise distributions for 8 or 9 years, starting in one of the RHEL 4 updates. My cunning super secret plan for world domination is kind of coming to fruition now, in that it's now used in Debian, Ubuntu, Mint, Oracle Linux, a long list of Red Hat products. In fact, even SUSE Enterprise are using SOS now, although not in their main distribution. I'm hoping to fix that once I get an OpenSUSE account and start getting packages in there. So, with all that said, let's jump into the main adventure, if I can get back to the right OpenOffice bit. What's going on there? My slideshow is broken. Let's just restart that. It's a good job I was on the first slide. Okay, so I did mention it was an adventure. This looks familiar to anyone, the older people, I guess. I realised earlier in the week my cultural references may be off kilter. I'm convinced I'm still young, but the grey hairs are showing now, and this is the kind of stuff I grew up with. Anybody else play these things?
Way too much.
Excellent. Glad to hear it. So you guys are going to get all the jokes today. For those who haven't played, this is the original adventure text. I just changed cave to cloud, but I thought it was quite funny. Yep. Okay, a note for the wise, never ever try and do that in OpenOffice. I nearly lost my sanity this week. So, you're standing at the end of a road before an enterprise support department. Around you is a community of customers, partners, and developers. A small stream of bug reports flows out of the building and down a gully. Now we're in the support department. You're inside a building. It's the support department of a large enterprise vendor. There is an XZ compressed tarball here. Oh, hey, look, it's an SoS report.
Not to get tarballs.
So, let's just have a brief interlude. For those of you who haven't come across SoS, helps if I qualify that a bit, we've got, here's our XZ compressed tarball at the top, with the slightly horrible date strings. That's on our issue list at the moment. They really make my eyes hurt. And you can see here the layout of the tarballs. Come back to that in just a second. Inside the report, we find configuration, log files, and command output. In fact, the structure resembles a root file system. This is deliberate, with some additional metadata. And this form of data is the currency of support information at Red Hat, and slowly spreading through other distributions and pies. This gives us a remote view into a machine. One of the things that upstream doesn't always understand, when you are supporting a product as opposed to debugging a project, you often aren't just debugging one simple, well-defined, confined component. You're debugging an entire machine. And today that machine might contain many more machines. And this is why we need the ability to get a somewhat more complete, overarching view of the system. And this is the problem that we aim to solve in SoS. Now, this isn't a new problem. The commercial Unixes all had this, and they tended to ship a really nasty shell script that was about 5,000 lines long, ran for a considerable amount of time, sometimes did strange things. I'm not saying we don't sometimes do strange things either. And in fact, Red Hat started out with just the same thing. We had a script called sysreport. Was, shall we say, fast and loose with input validation, and was retired after some incidents when people noticed that if you said your name was $open parens rm minus rf / well, you can figure out the rest, right? No more root file system. So SoS was started by some other Red Hat seg engineers, Steve Conklin and Pete Grainer, as I said, about 10 years ago, with the aim to be a somewhat more structured, organised approach to the same problem the Unix Explorer scripts had been trying to solve for decades. And one of the things it implemented was a plugin, or plugin. It's a Colossal Cave reference, in case you hadn't guessed. SoS plugins is the directory where our plugins live within the source tree. It contains an awful lot of Python these days. We've got about 167 plugins in the current tree. That's on master. There's a few more or less on some of our running topic branches. This has bitten us more times than I would care to mention. If I could go back, if I had a TARDIS, I would call these anything but plugins. Modules were rejected originally because Python has modules, and that would be confusing, right? This was more confusing. The thing is, if you say something's a plugin, people kind of assume that they're at liberty to do what they like with that interface. That they can ship modules in their own code, and really this was our mistake. We should have communicated much more clearly how we expected people to get new functionality into the project. It turns out that including this all in the main tree, at the moment, more to say on that later, is the most supportable approach. We've had loads of problems with downstream users kind of taking a hatchet to the plugin set and going, yeah, we don't need any of that stuff. Move it all around, change it around, mix it up. A number of problems with that. One, you end up with non-standard formats and data in different locations depending on where the report came from. Sometimes you can't avoid that. If the report came from Debian versus Fedora, those distributions put things in different places, so we can't really fix that. But if we're getting two reports from Red Hat systems, say one rel, one rev, we really want the same information in the same place so that when we write tools to automatically analyze and report it, they behave consistently and we don't have to have kind of lots of the Python equivalent of hash if def goo to kind of stick it all back together. This has tested my sanity on more than one occasion, and I'm kind of slowly getting things back to where we want them in terms of a same plugin set in our own code and good interaction with other groups who need support for their products and projects. One of the mistakes I made early on as a maintainer, I've been maintaining downstream for about 5 years and upstream for the last 3 or so. One of my mistakes was when people had a tight schedule and they couldn't define their requirements in time, it would be, oh, well, let's just agree an interface. We'll have a script called foo-debug and we'll run that. It kind of works around the schedule problems, but it creates a lot more further down the line. We have no visibility into what those scripts are doing. One of the things SoS needs to do is allow passwords, keys, and other types of secrets. And we can't do that when we're calling an external script. We'd have to kind of guess and just apply fuzzy global regexes to it, and I'm not very comfortable doing that kind of thing. And that leads us into the debris room. We now have a proliferation of these scripts. They are problematic, and I'm working to kind of merge functionality where it makes sense, to provide generic functionality. One of the knock-on problems that comes from this, when we try and bring those scripts into the fold, is some of the crazy debug techniques that upstreams come up with. There is a particular, how can I put this without making it too obvious? Storage-related thing, I'll say no more, where you have to send magic signals to processes that you grepped out of here and then, magic files in temp, with an asynchronous and kind of hard to predict delay. Neil, so I don't know why you're shaking your head now. And this reminds me of the Zuzzy magic word from the Colossal Cave. Upstream developers, help your downstreams. Give us nice, conventional debug techniques. What works best for us is a command we can run. That's simple, it's got a well-defined interface. We try to avoid complicated things like signals within the SoS code. We can do it if we have to, and again, I'll come back to that topic a bit later on. But it really makes everyone's life easier if we have simple, clean mechanisms to obtain debugging information from the system. Of course, there are certain situations where, because of the properties of the project or the part of the system, that's not always going to be possible. Generating a VM core from within SoS report is always going to be kind of tricky because we like to run on the kernel. If it's crashing at the same time, that's not going to work. So there will always be exceptions, but for regular software that runs in user space, it should be possible to provide reasonable, usable debug interfaces for that. The other problem that we've encountered is what I would call, I guess, a productization problem. There's this horribly overused cliche of go-to-market. But the thing is, the open source community doesn't really produce readily consumable output. Sure, anyone whose first experience of open source was trying to compile the Linux kernel and add support for their sound card in the late 90s, that was me, knows how intimidating this can be. Now, the exception to that, of course, is the distributions, where the whole point is you're trying to pull together all of these different products and beat them and hammer them and hit them with a chisel until they fit together in some kind of a coherent whole. Again, we kind of run into some interesting approaches with some upstreams. This is based on a true story. The names have been changed to protect the guilty. Clusters are complicated things. Finite state machines are complicated things. Passwords are not. Passwords are simple and secret. And taking them away shouldn't do anything bad. I've had a rather protracted discussion with some developers about the fact that their finite state machine treated password values as part of the state machine. And that meant if you changed or removed the passwords from debugging data, the state machine behaves differently. Which makes it rather hard to debug when you have security-conscious customers who set strong passwords and expect them to remain private. You have to go back to the customer and say, hey, I know you already set up your 12-node cluster and it's not working very well. Could you just set up another 12-node cluster and set all the passwords to Red Hat, and then we'll be able to help you debug it? I'm kind of exaggerating for effect here, but this is a real-world case. And if you think about support requirements earlier on in the project development, it's much easier to avoid these sorts of things. We have a plan in place to deal with this now, but retrofitting this to an existing piece of software is harder than just designing it to not require the password value up front. This has a serious impact for customers. I'm sure everyone that I can see here from GSS has encountered situations where customers refuse to provide data because they're concerned about information leaks and privacy. As I said earlier, it's one of the things that we have to do in SoS to kind of clean up the data and remove information from it. And if we just flip back to the terminal, wait that one in a second. And I'm just going to grab so you can see each of these plugins. Let me make that a bit bigger. It's kind of readable at the back, sort of, if you've got good eyesight. So each of these plugins is defining a post-processing method. This will get called after the files or command output have been copied into a temporary archive. And we can perform, well, pretty much arbitrary Python operations on them, but more about why you shouldn't later. The main thing we do here is regex search and replace. Just match a password field, replace the password with asterisks or some other character to indicate it's been elided. And you can see when we look down the list of plugins, kind of obvious ones, LDAP. LDAP is your directory system. It can be used for authentication. You can store password values within that directory of information. And obviously we don't want to carry that over into the report. Some that may be a little bit more unexpected in there. Overt. Overt has authentication. Grub2 and Grub1 also both support passwords. If your machine is in a publicly accessible area, or you don't trust the guy that sits next to you not to root it when you go for a coffee, you're going to put a bootloader password on so that they can't boot with arbitrary kernel options or into a different kernel or init ramifest. So far, we've got about 25% of the plugins with these sorts of post-processing filters. If you use SoS and you notice any places where information leaks through, file an issue with us. These are among the simplest bugs to fix, but because of the proliferation of different configuration files and types, and there's sometimes not great documentation for them, it's kind of difficult to identify all of these up front. And I'm kind of making excuses there, but also kind of not making excuses. There is only a finite amount of time, and when you run an SoS report, for those who've never seen it, let's go to that tab. We do warn about this. So here's a nice piece of legalese that's been reviewed by very expensive lawyers. Generated archive might contain data considered sensitive by the originating organisation and should be reviewed by third parties. If you're using it for kind of personal support reasons, moving data around, it's not such a concern. But for enterprise customers, they can get very sensitive to the information pulled in here. Although one thing that kind of amuses me, there is this upstream project called SoS Cleaner that tries to do additional removal of data. It's very effective for some things, but the reason we haven't merged it into SoS yet, it takes an interesting approach to IP addresses, which some organisations do consider secret. Why? I don't know. But it basically turns them into a random incrementing integer. So, found an IP address, that's 1. Found another IP address, that's 2.0.0.1. It also does this for multicast addresses. It stomps across subnet boundaries. We'd really like to include that because it's a feature that we keep on getting asked for. So if anyone's a IP arithmetic guru and has a good mangling scheme that preserves at least a reasonable level of the diagnostic information.
On the network side, there are tools out there that do that. They would just take the networks and replace them with some other networks.
Yeah.
So there are tools already.
Okay, great. So that was my question for the SoS Cleaner developers, and they kind of came back and said, "It's really hard. Let's go shopping." So
that's a standard problem in the networking space.
Right. Yeah. I think I've been meaning to start a thread on one of our lists for like a year now, but it's just somewhere way down on the ever-growing list of priorities because I'm sure that this would be a solved problem. And we would like to pull these features in and get them upstream because they do come up very frequently. I'm sure, especially the technical account managers in the audience are familiar with the concerns that customers have about confidential information from their environments leaking out. One of the things that does kind of make me smile there, though, is you'll get a cleaned SoS report with these mangled addresses in, and the next attachment is a VM core with no stripping, or a TCP dump, full binary TCP dump. You know, you've got customer social security numbers, credit card numbers, home addresses flying past, and you think, you guys really don't know what you're sending here. And that brings me to one of the other challenges that we have with SoS, and this is the numbers game, really. SoS is not a big project. It's not a complicated project. Most of the code is dumb as rocks. I know that because I wrote it. What makes it a difficult, or at least challenging, project to stay on top of is the testing matrix. We support today something like 8 or 9 distributions. You can triple that in some cases for the different versions of those distributions. Then you can multiply it again by product variants. And this presents something of a testing problem. When we kind of pull out all of those requirements, this means that I have to keep around 2 or 3 versions of Red Hat's clustering software. a number of installations of enterprise virtualization pieces, also the upstream overt versions, because they're different, they change. We also have things like directory server and Red Hat certificate system, and a continually growing list of products, projects, and other components that we support. And I kind of need to know how to configure all of those and test with them. Obviously, my time is finite, and I'm not a deep expert in all of those things. I'm certainly not a certificate system wizard or a directory server guru. But I need to at least make sure the basic default configurations work correctly when we push a new release out. And one of my nemesises that we're going to get into on just the next slide actually turns out to be my saviour here, hopefully. We've got a plan upstream to introduce a new testing framework. And the way that this is going to work, we will take a report from a machine, we chop it up, take all of the command output, and then turn each piece of command output into a shell script, which just echoes back the data that we got the last time we ran it. We can then take all of these fake binaries, inject them into an image, and run an SoS report against it. Now, this isn't as thorough as testing with a full installation in multiple different configurations, but the fact that we can capture them, store them in a repository, and then rerun the tests against them again and again and again gives us a much stronger regression suite than we have currently. Today, our regression suite is a set of upstream unit tests and downstream quality assurance tests that are done by the different vendors. So we have an awesome team at Red Hat doing that for SoS, led by a guy called David Katalak. They have worked very, very hard on the set of tests that we use, and very often they will find bugs that I haven't noticed. We're hoping to start getting some of those benefits in the upstream space using this mechanism. And, injecting commands into images and storing them in a repository, that sounds like something trendy. So we're planning to make our new testing architecture use Docker. We'll use a repository to contain the regression tests. We can then launch containers and run the reports in them, obtain the output, automatically check it, and hopefully have a strong way of verifying that new code and new changes are correct and are not affecting the behaviour or the data that we collect. And just in time too, because we just pushed a very complicated set of changes through. For the last 2 weeks, I have been stuck in a maze of twisty little containers, all alike. For those of you who haven't played with Docker and the other kind of container approaches like LXC, they allow you to partition a system on a single kernel, so unlike thick virtualization where you boot a new kernel using software, we just carve off a little slice of the system, confine it to some degree, or not, more on that in a moment. But this introduces a number of complications for SoS. First of all, we've got these containers running, but the containers are generally a very stripped down environment. If I want to run a web server in a container, I'm going to put a web server in the container. I'm not necessarily going to put a whole Python runtime in there if I don't need it. I'm not going to put the other support tools that SoS wants to run in there. I'm going to keep it a lean, stripped-down environment. So how do we then enter that environment and run the commands that we need, collect the files we need to obtain the support data? And there are a couple of mechanisms for doing this. We can use the nsenter command. For people who've not played with Linux VFS namespaces, these days a process can choose to detach from the main namespace, or rather its parent's namespace, and unmount and mount file systems those changes will not be visible to other processes that are not in that namespace. Now, namespaces have been around for a very long time, at least 10, if not 15 years. Alviro did virtually all of the work to make these function upstream back in the 2.5 and early 2.6 days. They were little used for a long time. They were actually a feature that came from Plan 9, not from Outer Space, the movie, but the Bell Labs operating system that some of you may know. In today's world with containers, namespaces are of much more importance. And this brings us to another fun piece of current development. Who's come across Atomic? Okay, some hands go up. Yeah, so it's still kind of new, and it's a new approach to managing the host on which you run your containers. I actually played around with something like this about 6 or 7 years ago, and everybody said that I was crazy at the time, and I gave up on it. I called it PIG, or Packages in Git, and it was a set of scripts that you built your code and then checked the result into Git. And then you could check out atomically different states of the builds over time. Anyway, somebody else came along and did it properly, and this is the OS Tree project, Colin Walters from the GNOME teams. The idea with Atomic is you atomically update the operating system, and it's a very, very stripped down environment. There are no tools here. Again, this is a challenge for SoS because we rely on running tools. Tools are the currency of information that we deal in. And somebody had the idea of the super privileged container. Dan Walsh, who works on SE Linux, who you may have seen speaking yesterday, came up with this notion with some discussions with our container developers. I sometimes call this an uncontainer because it doesn't really contain anything. It's in a different namespace, which means we have to use funny paths to access the real root file system. But it's at the same privilege level as the main host. It shares the process ID, network, and file system namespaces. Sorry, not the file system namespace, the RPC namespace. And this kind of means that SoS has to do this funny dance. So we've got one foot in the privileged container and another foot in the atomic host. But this means that we can cross the boundaries and obtain the information from it. Implementing this was kind of interesting. If I just switch over to... sorry, I forgot to get my browser on the right screen. There we go. So, I'm not going to go through it, it's just a boring list of commits here, but just to give you an idea of the level of change that was required, we effectively had to implement change root support for SoS, so it takes a sysroot parameter now, which tells us where the atomic host's root file system is. Originally, the idea was that we were going to run all of the commands from this super privileged container. It turns out some of them, as yet, don't work inside the privileged container, and we have to run those on the host. So we also had to add support for change root commands. Now, at the moment, this is a bit of an ugly hack, but we're going to work on improvements for this upstream to use the nsenter command instead. If anybody is interested in working on this, it's a very active area of development at the moment. I've been doing virtually all of it myself, but there's a lot of scope for more testing, supporting different environments, and adding new features. So, before we finish up, I'll just take a quick tour inside a plugin. Now, I mentioned earlier about the freedom that the interface gives you. You can do anything that Python lets you do. And actually, that's a bad thing. Especially some of the plugins that were contributed in the early days are this kind of sprawling mess of matted tangled, horrible code that, because of some of the problems I mentioned earlier, we're never too confident about being able to test properly. One of the most joyful tasks I have in maintaining SoS is deleting large pieces of code. We have an ongoing effort. I mentioned earlier that we don't like out-of-tree plugins. The problem is the downstream guys love out-of-tree plugins. What we're trying to do is eliminate imperative code from the plugin model. We want to have eventually purely declarative plugins. You declare the files you're interested in, the commands you're interested in, the packages or other triggers that should enable the plugin. That way, we don't have these concerns about a third-party plugin going off into the weeds and trying to collect the entire root file system or all of your virtual machine images. That's happened before. Clearly suboptimal for the user experience when you try and copy a 100 gigabyte file system into a directory that's inside that 100 gigabyte file system. And remember, this is usually on a system that's already having trouble. So your customers love you when that happens. And saying, well, you know, it was these downstream guys, not my fault, doesn't really cut a lot of ice there. Something that kind of happened by accident over the last few years was that we became portable. Originally, this was done so that we could run SoS under the Jython runtime inside a JVM and collect support data for JBoss. In the end, that kind of got canned for various reasons. It's very, very hard to keep it running, even harder than the Windows and OS X ports. But then some folks from Debian came along and went, hey, this is cool. And a former colleague of mine who's now at Canonical kind of went, yeah, we like that too. And they used the portability framework that we put in place to allow JBoss to work to port to other Linux distributions. And this is what's kind of caused SoS to now proliferate into many different places it didn't used to get through. That said, you do need to take special steps to avoid different binary locations, different file locations, and other problems that will come to bite you. And just take a look at, say, the Apache plugin. What we have now is a mechanism called tagging classes. So Apache is a plugin, Red Hat Apache is an Apache plugin, and a Red Hat plugin. And it does all of the Red Hat paths and locations. Debian Apache is an Apache plugin, a Debian plugin, and an Ubuntu plugin. And it just modifies the paths here. Now, eventually, as I was saying on the last slide, what we want is to just have lists, just lists of information. The plugins then are really short and simple and easy to maintain. People can distribute them in their own packages without causing us problems or our users. And this is the direction that we're moving in. We're hoping this will be finished for SoS 4, which is kind of planned in about a year. But all of the container support and the change route support that I've been discussing is landing in 3.3, which should be coming out in about 4 to 6 weeks. Okay, so thanks for listening. Does anyone have any questions in my minute or two remaining?
So, in the new model that you're going to go to, do they have output is just drop something into that directory or work? Or do they have SOS?
In the model that we're working towards, there will be a public plugins directory. It's not going to be under user lib, because that's where the in-tree plugins will go, which, again, kind of... I didn't have enough room to talk about this topic in the 40 minutes, but we're trying to move to a structured data model. It's been ongoing for a while, but eventually all of the in-tree plugins will populate this data model, and the out-of-tree ones will go under user share SoS plugins or something like that. And packages can drop their plugins in there, but if we find a plugin in that location that defines a method, we won't load it. So third-party plugins will not be allowed to introduce new code, only data. the classes will be pure data classes.
So for to get another functionality, they will have to submit a patch upstream to allow for the use it in.
Right now, that's what we prefer. I ask people to do that because it's usually simpler on all parties. The problem is if people don't send the stuff upstream first, or at least send it to our developer mailing list, speaking of which, we don't have any visibility into it, and often it's shipped to end users with what we would see as serious problems. And once it's in the hands of users, it's harder to backtrack, to fix those and to correct them. Thanks for your time. Tonight, unfortunately. Not till late. I'll be around all afternoon. Cheers. Hey, good to meet you. Yeah. If I'd have known, I would have given you a name check because you guys really do an awesome job.
Change our approach so more upstream and less downstream.
Cool. That would be brilliant.
This is news for me that I'm changing I was hoping to talk about it with David. If you're meeting tonight, I don't think
Yeah, David and I have discussed the Docker testing framework on IRC a few times. I really think it's our best way of moving some of the integration testing rather than the unit testing into upstream. Cheers. Yeah, I'll see you again. I'll catch up with you later on today. I'm just going to get myself unhooked and out of here. Hey, how you doing?
I don't know if we've ever met in person.
No, I think we have.
Good presentation. Very enlightening. I only have one question. The password thing with exploding state machines, that wasn't
Not ready.
good. Okay. But you kept saying cluster up there, I'm like, shit, what did I do now?
No, well, we'll take that off.
Okay. Well, yeah, describe me if you want to
It's fixed now. Basically, it's an upstream thing. And there's two Red Hat guys now fixing it.
you know whatever?
Yes, but not off the top of my head. It's in above.
Okay. Yeah. Catch up with me on that later.
Yeah. It's a bit crazy, but I'm really glad we've got something together for GA. Yeah, no, really happy. No, you're welcome. Yeah, we'd love to. Yeah. Very interested in K-Patch. Cheers.
Some comments?
Yeah.
So, if you merge something that is mangling IP addresses, please make sure that it's clearly identified as the addresses are mangled. I mean, there's nothing worse than getting data that you just for a customer.
This is why I will not merge SoS Click.
Okay.
That's this third-party tool, and it strafes the data, and I know our financial customers love it because they get this warm, fuzzy feeling of security, which is stupid. Our support guys hate it. They get these reports, and all the IP addresses are nonsense.
Yeah,
And then half the time,
I mean, if they are nonsense, then at least it should be obvious that
but usually you've wasted half an hour or an hour because they don't look totally stupid. It would be like 10.0.0.1, 10.0.0.2. You know, if they were like 255.255.255.1, okay, that's clearly bogus.